Hello people, welcome to another episode of the video series where we learn Kotlin with Codecademy's Learn Kotlin interactive course. In the last lecture, we went through the conditional expressions, and now in this lecture, we will learn about collections. Let's get started with the lists. In this section, we're gonna explore the various types of collections that exist in Kotlin. A collection is a group of elements that exist in a single structure. The first collection type we'll learn about is one that's most commonly used in Kotlin and many other programming languages, a list. A Kotlin list is very much similar to a real-world list. It represents an ordered collection of elements that can contain duplicates. This part is important. A list can contain duplicates, okay? These elements can be of any primitive data type and represent a myriad of real-world scenarios. These can include student grades, restaurant ratings, a to-do list of tasks, and more. So let's go ahead and see the syntax. For example, we use list of here to create a list. Okay, in Kotlin there are some helper functions like this: list of, array of, map of, set of, mutable list of. We will see those later. These helper functions are used to create lists. It's the most convenient way of creating lists. It's a function, but it returns, this whole thing returns a list structure, okay, a list data type. And here you type the strings or integers or whatever you want to put inside the list side by side, separating them with commas because this is a function and these are the arguments of this list of function, okay? And with this structure, you can create a list of gather wood, start a fire, set up a tent, eat dinner, stargaze. So this list contains these elements, these items, okay? So this list has 1, 2, 3, 4 and 5 elements or items inside. If you print this list using println, it'll return a structure like this. In Kotlin, when you print lists, they include some brackets here and there, and all of the items are printed separated by comma. Okay, it also talks about arrays a little bit. It says arrays also have a similar structure, but arrays in Kotlin have a fixed size, whereas lists have variable size. So if it's like a mutable list, for example, you can keep adding elements later on in the code. Okay, and Codecademy says, since arrays have a fixed size, we'll be focusing our time on exploring lists instead. But we encourage you to read up on arrays in Kotlin's documentation. I don't think you should right now because lists are very similar to arrays in so many ways. So after learning lists, you can just solve some problems or like do some little reading afterwards so that you will understand what is all about, okay? So let's go and hit next so that we can start learning. In Kotlin, we have mutable and immutable lists, but don't confuse those with var and val keywords, okay? This represents the immutability of the variable, whereas mutable and immutable lists represents the mutability of the list itself. So what does it mean is if you have an immutable list, once you put elements inside, you cannot add elements later on, or you cannot remove any items from this list, or you cannot change the values inside, okay? You cannot update the second item, for example. But if it's a mutable list, here, mutable, then you can remove items, add items, or update items. These are all allowed. So And you can use both var and val with both of them. So you can have a mutable list, but you can have a val, or you can have an immutable list and you can use the keyword var, because again, var and val is different than the mutability of the list. This represents if you can mutate the value inside this variable, whereas mutable lists and immutable lists are all about changing the values inside or adding items later on or removing items. Okay, you will understand the difference later on. If you don't right now, don't worry, just keep reading. And for a list to be used and referenced throughout a program, it must be stored in a variable. Make sure to use keywords val or var in your declaration as well as a descriptive list name. The creation of the Kotlin list begins on the right side of the assignment operator with the term list of. This indicates an immutable list. So how we create immutable lists is we use list of function. The term, the list of, is followed by a pair of parentheses because it's a function that holds a collection of elements separated by commas. Like variable declarations, the type of the list can be inferred by the compiler or declared by the user. For example, a list of string values would be referenced as list of string. So this is how you read these kind of generic types, a list of string. So you use a smaller than symbol and a greater than symbol here and there, and then you put what it's containing inside this collection. So this means list of strings or list containing strings. And once initialized as a list of string, that list can only hold string values. You cannot change the type of it. Cool. For example, here we have a countries visited list, and to define this list, we started with the list of function and then keep feeding it with Japan, Colombia, Kenya, and Jordan. Okay? Since countries visited was declared a mutable variable with a var keyword, we can reassign the value of countries visited to store a different list if we would like. So this is actually a really good example because we told that list of is an immutable list. So we cannot add or change the variables. But since this is a variable, like a mutable variable, we can change what we store in this countries visited. We can store another list, for example. Okay, we can feed it with another list later on in the code. Let's see it here. For example, let's say we have this list. Okay, what countries visited, blah blah blah, and afterwards in some point of code we can change this countries visited. We can come here and create another list, okay, another immutable list, and feed another list of countries, for example, Turkey, Germany, and let's say Azerbaijan. Okay, we can do that. However, we cannot change elements of this list. We cannot use operators on countries visited. We can reassign it. We can reassign it because this is a var. If this was a val, we wouldn't be able to change what is inside this variable, assigning a different list. Okay, we cannot do that, sorry. So this is the difference between the mutability of a variable and the mutability of a list. We will see, I will talk more about this later on because this is a very confusing topic if you're learning it the first time. So I'm gonna come to this example later on in this video. Okay, so when you print this, again, the printed string starts with a bracket and then lists all of the items and then finishes with another bracket. Square brackets, not parentheses. We've learned a handful of rules and new concepts in this exercise. Don't get discouraged if it doesn't all stick right away. We will be getting ample practice throughout this lesson. Keep going and let's create your first Kotlin list. Yes, this is something you may not understand at the first time, but later on you will know it. You will learn how to use all of this stuff. Cool. So in Sports KT, create an immutable list. To create an immutable list, we use list of, okay, containing the following water sports: windsurfing, sailing, swimming, jet skiing, water skiing. Okay, so I can use a var, I can use a val. This is not important. An immutable list is not related to not related to the mutability of the variable. So I will use var, and it should be called water sports. And to create an immutable list, I use list of. If it was a mutable list, I should be using mutable list of, but we will see it in the next exercise. So list of windsurfing, let me copy and paste, this will be quick. Windsurfing, sailing, swimming, don't forget the commas, and after each comma I also put one space, okay? After the comma, not before the comma. Comma comes here, and after the comma there is one space, like we do it in English. Okay, let me adjust this a little bit. Yeah, you need to put space here, okay? And then you end up with a parentheses, because this list of is a function that creates a list of the given arguments. Cool. Let's run this and see if we have the check mark. Nope, we didn't have the check mark, because by mistake I put two parentheses. Okay, I need to delete one. Let's run this now. And now we have a check mark. And in the second step, output the value water sports using a print statement. This is easy. What I need to do is to use a print or println and then give water sports inside. Since this is a list, it'll be printed different. And let's see how it gets printed. Yes, it gets printed with brackets and all the elements separated by commas and another square bracket. Cool. Next exercise. Accessing elements in a list. Yes, if we have a list, we want to access each element inside. So we use indexes for that. For example, if we want to reach to access this element, we will say, okay, let's get the element at 0th index. And please note that the index starts with 0, not 1. This is because Kotlin is a 0-based language, and the count in every Kotlin collection begins with 0. This is also same in a lot of different languages actually. Java is like that, C is like that, C++ is like that, C# is like that. So many languages, they all start with 0, okay, when you start an index. So if you want to get this element, you will say, okay, give me the 0th item. Or this one, you say, okay, give me the first item. And for that, give me the second item. So this has 3 elements, but the last index is not 3, but last index is 2. This is because we begin to count with 0. And the syntax for accessing any index or any element is like this. You put the list name, for example, Oak Island artifacts or another thing, and then you put square brackets and then type the index inside. For example, if you want to get Oak Island's artifacts 0th item, Oak Island artifact 0th item is this one, okay? And you can get it like this. This will return lead cross. This will be evaluated into lead cross, or the first one or the second one. And there is a note here. Attempting to access an element within an index that does not exist will result in an error, and that is called array index out of bounds exception. For instance, if there are 2 elements within a list and the specified index is 5, the compiler will throw the following out of bound error. Okay, let's go ahead and do this exercise. In this exercise, it asks us to create a variable, give it this name, United States Marathons, and store a list of marathons, which are Boston Marathon, Bank of America Chicago Marathon, TCS NYC Marathon, and Marine Corps Marathon. Okay, let's run this. We get the green. So it says access Bank of America Chicago Marathon using square brackets and its index in the list. Wrap this code in a print statement to see the output. So first thing, how to access to any index. We type the list name and then use a pair of square brackets and then the index of the element we want to access. And here it is Bank of America Chicago Marathon, which is the first element. See, this is the 0th element and this is the first element. So I'm going to type 1 here. And it also says wrap this code in a print statement to see the output. So I'm going to wrap this in println to see the value in the console. Now it printed Bank of America Chicago Marathon because this is Bank of America Chicago Marathon, a string, and now when it's printed it looks and shows as is. Okay, we saw immutable lists. Now let's see mutable lists. Mutable list means you can add items, remove items, or update items, okay, after you initialized it. So let's say we have a list like this or like this, then we can assign a different value to the 0th index, for example. This is updating the element at 0th index. So instead of going to school, it'll write swimming at the beach. And when you print this list, it'll print swimming at the beach because the 0th has been changed now. And then attending tennis practice because it was here attending tennis practice and reading. These last 2 haven't changed, but the first one, the 0th one is changed. By the way, when you create a mutable list, you use mutable list of function. It was list of for immutable, and it is mutable list of for mutables. Cool. Let's apply what we learned now. Create a mutable list, open Broadway shows. Okay, Rebel, open Broadway shows. We can use also val, by the way. Both of them are valid, okay? Var or val. Open Broadway shows. It should be a mutable list. So I'm going to type mutable list of. And then keep adding the elements inside. The Lion King, Chicago, and Miserables. Cool. After I edit them all, I will run and see the green. Now I need to change the share show, which has been closed as of August. Let's remove it from the list and replace it with a show that's still open, Wicked. Okay, how to do that? I need to first type the list name and then access the item, which is in 0, first and second index. So I'm gonna type 2, and then now to change this, I'm gonna use an assignment operator and change it to Wicked. Now this operation will overwrite this and type Wicked here, okay, in the list, not to my code, but in the representation of this list in the memory. Yeah, we forgot to output the list, so also after doing this change, I need to print open Broadway shows and see the end result, how the list is affected by our change. There is a typo here. Yeah, see, now Wicked is here in the place of the share show. Okay, cool. Now let's learn about the size property. Size property determines the number of elements within a collection. It is not only applicable to lists, but also to other collections like map or set, okay? Similarly to the length operator for strings, size counts the number of elements in a collection and returns an integer value. Take a look at the following list of major European rivers. Okay, we have another list, okay? And now if we type dot size without a pair of parentheses, because it's a property, not a function, then it'll return 5 because there are 5 elements in this list. And if you want to print this, you can print it like this, or you can wrap it with a $sign and a pair of curly brackets to inject this value inside the string. So after doing that, it'll print there are 5 major rivers in Europe. Furthermore, size can be used along with an element's index to retrieve the lost element of a collection. So this example can be confusing to you. Let's see what's going on here. So major rivers size -1 is an integer, right? Like 3 or 10. In this case, since major rivers size is 5, this will be 4. And when you say major rivers 4, it'll be bringing the last item, because since everything starts with 0, this is 0, this is 1, 2, 3, and 4. In a list that has 5 elements, the latest index is 4. In a list that contains 10 elements, the latest index is 9. So it's always size -1. Here, it uses this feature of size -1 to get the latest element. Like this was 4, and the latest element is Elbe. So this will be Elbe, okay? And since this is Elbe, it'll print Elbe. So it works like this. It looks like long and scary maybe for some of you, but it's not actually if you go step by step. Cool. This strategy is most commonly used when iterating over a collection, or simply grabbing the last element of a list when we don't know how many list elements there are in total. We'll learn more about how to iterate over a collection later in the course in the lesson loops. In FruitKT, create a variable fruit trees. Let's do that. Fruit trees, and this should be a mutable list, so I'll go ahead and say immutable list of, and let's store those. Okay, I'm gonna use a trick here, and now I can run and get the green mark. So the next step is constructing the following sentence using string template syntax, and replace the value within the brackets with fruit tree size. Use a print statement to output the sentence to the screen. So let's start by the println. Don't forget to press the tab like I do. Println, and then I am growing blah 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 something here. Okay, different types of fruit in my garden. So I use a pair of braces here because I will use a complex expression. If it was just one thing, like one variable, like fruit trees, or some other thing, some variable, we can do that. But if it's some variable dot some property, I now need to use braces to wrap this whole thing, so that the compiler will inject this. Okay, if we forget to do that, what it does is it'll evaluate this, like let's say some variable is 10, and it'll write this 10 dot some property. Okay, so we need to use a pair of braces like this, and I want to print the size of my fruit trees, so I'm gonna use fruit trees dot size. Let's run this, and it says I'm growing 4 different types of fruit in my garden. So let's go ahead and, just out of curiosity, let's see what this will print. But before I go ahead and run, please try to imagine the end result. It'll be very, very different string if you do that. Okay? Go ahead and do your guess. And now I'm gonna run. See what's going on here? It said I am growing, and then the whole list with brackets and such, and then it shows dot size, different types of fruit in my garden. This is because now this whole list is injected into this string, being converted into a string like this, okay, with curly brackets and such, and then it continues as is, dot size, different types of fruit, because it didn't understand fruit trees dot size is a compound thing that needs to get evaluated. To do that, you need to use braces. I hope that is clear. Let's go to the next exercise. We saw one property of the list, which is size. Now see some functions. Every collection in Kotlin contains a series of built-in functions that allows us to perform certain operations in order to retrieve information about the collection or manipulate its values. A function that retrieves information about a list would only require read access, whereas a function that changes the contents of a list would require both read and write access. As a result of this, immutable list supports functions that possess read and write functionalities, whereas an immutable list supports functions that possess read-only operations. Let's take a closer look. Here we have an immutable list. How do we know it's immutable? Because we use list of, okay, not not mutable list of. When something is not mutable, it is immutable. So list of A, E, I, O, U. And this is a list of vowels. So the contains function accepts a single value within its parentheses and return a Boolean true or false depending on whether or not that value exists within a list. It does not need to change the contents of the list, thus it can be used on an immutable list. So you can use contains on both mutable and immutable lists. And to use this, you type the name of the list, vowels here, and then put dot contains like this. You need to use dot syntax as you do when you're accessing properties or functions defined on those types. Okay, so vowels dot contains A will print true, but vowels dot contains B when you print do not print false, and the reason for it is this list does not contain B, but it contains the letter A. And also we have the random function, which also only requires a read-only access and returns a random element from the list. For example, vowels.random can print I or O or A, like a random selection. And now let's look at the mutable only list functions. So these functions are available only on mutable lists. To showcase those, it creates another list, but now it is a mutable list. It uses mutable list of function to generate this list. And it gives 4, 5, 7, 11, 13 into the list. So we have these prime numbers. So we have now the list of prime numbers. But there is something wrong with it because 4 is not a prime number, right? I think it'll remove it after it adds 17. So when you add something to the list, it adds to the end. So it uses prime numbers dot add 17 to add this 17 here. So when you print this, now it prints 4, 5, 7, 11, 13, 17. But after you remove 4, okay, remove 4 means remove the item 4, not the element at index 4. There's another function for that. But here it removes the item 4. And when you print it, you'll see 5, 7, 11, 13, and 17 is now here. And after you remove it, all of the indexes are changed because now the 0th index will give 5. Before it was giving 4, and first index will give you 7, whereas it was giving you 5. So on and so forth. All of the indexes are updated. If the value to be removed does not exist, the compiler will not throw an error and simply returns false. Okay. These functions are just the tip of the iceberg of what's supported for lists in Kotlin. We encourage you to look through the documentation for immutable lists and mutable lists to explore other available functionalities. Yeah, the collections in Kotlin are really powerful. So you have lots of properties and functions. You can check out those if you like. Okay, in planets KT, we declare the mutable list containing of the names of planets within our solar system. We'll use Kotlin built-in list functions to fix some of its inaccuracies. First, use the remove function to delete a planet that does not fit in the list. Check the hint for help. Yeah, so it's because of the Pluto. As you know, Pluto is removed from the list of our planets by NASA, I guess. Or some other organization, I cannot remember, because it's not a planet but a dwarf planet, I guess. Correct me if I'm wrong. So to remove this, it's easy. We'll type planets, the name of the list, and then remove, and then Pluto. Okay, let's run this. Yes, We passed it. There is one planet that's currently missing. On the following line, use the add function to add it to the list. Hint, it's the only planet in the entire solar system with a liquid surface. Okay, Mercury, Venus, and the third one should be Earth, right? So let's add Earth, our planet Earth. Planets dot add Earth. Let's run this. Yay, we passed it. So implement the random function on the following line to generate a random planet from the list. Make sure you wrap your code in a println statement to see the output. So like this, println planets random. So now it generates Mercury, but if we run it for a second time, it'll bring some other one. Venus, for example, or Venus again, or Mars now. Okay, it just picks a random one. It can bring Earth or Uranus or Neptune. Okay, let's review. In this lesson, we've learned the following concepts. A list is a type of Kotlin collection that contains ordered elements. An immutable list is declared with list of and indicates a list whose values cannot change throughout a program. A mutable list is declared with mutable list of and indicates a list whose values can be altered. Elements within a list can be accessed using their index. The size property returns the number of elements in a collection, like the length does for string. Okay. Immutable lists possess read-only functionalities. Meanwhile, mutable lists support both read and write functionalities. The contains function checks if an element exists in a given list. It returns a boolean true or false. The add function appends an element to the end of a mutable list. The remove function removes an element from a mutable list. And lastly, the random function generates a random element from the given list. Okay, we've covered the major fundamental programming concept used in most programs to store and manipulate data. Feel free to utilize the empty review KT file and output terminal on the right to hone your understanding of lists and practice writing Kotlin code. Okay, let's now do a final exercise. Let's say I have a list of subscribers, okay, to my YouTube channel. Subscribers, and it is a mutable list of, let's say, Safa, John, Mary, and let's say Burak, a Turkish name. So let's say you there is a you here, you, and this you is your name. Okay, I don't know your name, but if you do this, subscribers add you, it'll print your name, it'll add your name, sorry, to the list of my subscribers. And when we print the list of subscribers, then it'll show your name. Here, your name is here. Please go ahead and subscribe if you haven't, and see you in the next episode.